Hello students, welcome. Previously, lesson 9, form 4, topic 5, we were dealing with the second part of the chemistry of zinc metal. So today, lesson 10, will be proceeding to the fifth metal, that's the chemistry of lead metal. So in this class, we'll be dealing with number 1, the occurrence of lead metal, number 2, the extraction of lead metal, number 3, the uses of lead metal, and lastly, number 4, we'll be concluding with 3 extended questions. So kindly stay with us until the end of the video. So to start with the occurrence of lead, we are saying lead occurs as galena, and galena is lead 2 sulfide, and its chemical formula is PbS. Then we are having cerussite. Cerussite is lead 2 carbonate, and its chemical formula will be PbCO3. Then we are told lead occurs as anglesite. Anglesite is lead 2 sulfate, and its chemical formula will be PbSO4. And we are saying the chief ore from which lead is extracted is galena. And remember, we said galena is lead 2 sulfide with the chemical formula of PbS. So next, let's proceed to the second part of our class. That's the extraction of lead metal. And we're saying lead is extracted by the reduction of lead 2 oxide using coke, that's carbon, and carbon 2 oxide in a ballast furnace. So let's proceed to the extraction process of lead metal. And we are going to start part 1, that's crushing of the ore. We are saying the galena ore is ground into fine powder so as to increase the surface area for the extraction of lead. Then number 2, we are going to go to the concentration of the ore. The aim of concentrating an ore is to remove impurities, and we are saying the galena is concentrated using froth flotation. So let us see how it is concentrated, and we are saying the galena is ground into fine powder, then mixed with water containing special oil such as pine oil as a frothing agent. Then next we are saying froth rich in minerals is formed at the top while impurities sink at the bottom. Therefore we are saying the froth is skimmed and dried. That's how galena is concentrated by froth flotation. So number 3, we'll be proceeding to the roasting of the concentrated ore. And we are saying the concentrated ore is then roasted in air to form lead 2 oxide. And we are saying lead 2 sulfide, that's galena ore, is roasted in air to produce lead 2 oxide and sulfur peroxide gas. Remember learners, if a metal sulfide is heated or roasted in air, we will form 2 products. One is metal oxide and the other one is sulfur peroxide gas. So the equation for that reaction will be 2 moles of lead 2 sulfide solid reacting with 3 moles of oxygen gas. We are going to get 2 moles of lead 2 oxide and also 2 moles of sulfur peroxide gas. And we are saying the sulfur peroxide gas produced is an important byproduct which is used in the manufacture of sulfuric 6 acid in the contact process. So let us proceed to number 4, that's the reduction of the ore. We are saying the lead 2 oxide from the roaster is mixed with coke, limestone, silica, and we said silica is silicon peroxide, and some iron powder or some iron. And we are saying the mixture is then heated in a ballast furnace. So next we are saying the lead 2 oxide is reduced by the coke to lead, and the question for that reaction will be 2 moles of lead 2 oxide solid reacting with 1 mole of coke or carbon which is solid. We are going to get 2 moles of lead solid, and also we are going to get carbon peroxide gas. So next we are saying iron is added to the ballast furnace to reduce any remaining lead 2 sulfide to lead. And the question for that reaction will be iron solid reacting with lead 2 sulfide solid. We are going to get iron 2 sulfide which is liquid, and also we are going to have lead solid. Next, we are saying the limestone fed into the furnace alongside coke and lead 2 oxide is decomposed by heat in the furnace to form calcium oxide and carbon dioxide. And the question for that reaction will be calcium carbonate solid being heated decomposes to form calcium oxide solid and also carbon dioxide gas. Therefore, we are saying the calcium oxide formed combines with silica, that is silicon dioxide, to form calcium silicate. So the equation for that reaction will be calcium oxide solid reacting with silicon dioxide solid. We are going to get calcium silicate, which is liquid. So next we are saying the iron 2 sulfide and the calcium silicate form slag, which is tabbed off separately from the molten lead. Next we are going to go to the fifth extraction process, that is purification or refining of lead metal. And we are saying the lead produced by the reduction method is not pure, as it contains impurities such as gold, silver, copper, tin, and sulfur. Then we are told pure lead is obtained by the first way is blowing a blast of air through the molten impure lead. How is it done? We are saying oxygen in the air oxidizes the impurities into compounds which are less denser than the lead, and therefore we are saying these compounds float on the molten lead and are skimmed off. But B, that's the second way of obtaining pure lead is by electrolysis method. When we are saying more pure lead can be obtained by electrolysis, and the cathode is made up of a pure strip of lead, while the impure lead is made the anode. Then the electrolyte consists of lead 2 nitrate solution. So what will happen during electrolysis? We are told at the anode, the lead, that is the impure lead, dissolves, while at the cathode, lead is deposited at the pure lead cathode. So this is the electrolytic purification of lead, and we are having the anode made the impure lead, the cathode made the pure lead. Here we are having solutions containing lead 2 ions, and that is lead 2 nitrate solution. So let us go and see the reaction taking place at the anode and at the cathode. So to start at the anode, remember we are having the impure lead at the anode. So what will happen at the anode? Lead solid or the impure lead loses 2 electrons to form lead 2 ions, which are aqueous. That's why we were saying the anode lead dissolves. So what about at the cathode? At the cathode, lead 2 ions, which were aqueous, will accept the 2 electrons lost from the anode to form neutral lead metal, which will be deposited on the pure lead cathode. Next, let's proceed to the uses of lead. Number 1, we are saying its use in making car batteries, and that is lead acid accumulators blades. Number 2, we are saying its use in making gun burettes. Number C, or battery, we are saying its use in making protective clothes against nuclear radiation in a nuclear reactors, that is the alpha rays or the alpha particles. So number 4, we are saying solder alloy, which is an alloy of lead and tin, is used to join metal surfaces in welding or electronics. Then we are saying number 5, or but E, it's used to make lead bulbs. Next, let's proceed to the last part of our class, that's extended questions on the chemistry of lead. Learners, we are having 3 extended questions. So this is from question 1 and question 2. Kindly have a look at the questions. Learners, that's the end of our class today. Thank you for watching.